Folks, another question. I'm curious. Who is enjoying this type of work? Who enjoys it? It's better than the other ones? Doesn't it kind of feel like a puzzle? Like you're sort of like, no, you don't like it. All right, I'm a puzzle person and I love these. I don't know if there's a correlation. If you go under there is one. Oh no, I have one extra right here. You're welcome. Okay, number 11. Okay, so once again, I look at number 11. I see that the left side is a lot more complicated, so I'm going to just give it more space. Okay, and on the left side, I've got 1 over 1 plus sine theta. Is this too light of a color? Okay. Okay, so we're going to start on the left side because it looks more complicated. And right away, I am seeing I'm adding 2 fractions. So we are doing common, number 11, common denominator. I will post both the video and the sheet. Okay. So Sebastian, you like, because I'm going to post this, you choose if you want to just watch or like however you want to do this. All right. And so I've got space here. So I'm going to multiply. And folks, I want you to stop me. Like, if you're like, what are you doing, Miss Light? Just stop me, okay? Because I feel like sometimes I'm sick of my own voice. Does this step make sense? Good. And then I know that my common denominator becomes okay, right? And then I get 1 minus sine theta plus 1 plus sine theta. Okay, right away, I can, Angelina, ja цей документ поставлю на як PDF на інтернет. Тобі може краще таке слухати, ти рішай. So right away, I can cancel out the signs in the numerator. Agreed? We good? Yeah? All right. But the bottom, what do we do there? Aha. This is where we must remember the following. Also known as the Fleur rule. X minus 1 times x plus 1. This means that I multiply the first and first, or I just square the first term, and then I square the last term. So if I have 2 binomials that are identical, except for the sign in the middle, I will use the Fleur rule, also known as the sum and difference. So what does that look like? So in the numerator, yes. The sign and sign? Okay, so I'm canceling it out because this is simple arithmetic. Like nothing to do with here. I've got 1 minus 1 sign plus 1 plus 1, like 1 sign. So it's really like just arithmetic. So in the numerator, I'm left with a 2. Now watch this. Okay, if I multiply the first and first term, 1 times 1 is 1. Then I put a minus, and then I multiply the sign and the sign, and that gives me sine squared theta. Okay, so just check, do you see what I just did in the denominator? Because that was a big move. Are we good? Shake heads? Yeah? Okay, and then I'm like, oh, dang, that's the Pythagorean identity. Whoa, messy. Right? It's like, oh, 1 minus sine squared 2, instead of that, I can just write cos squared theta. Yeah? Now, do I keep going or do I stop? Just put your hands out. Go like, stop, Miss Sly. Stop, right? Okay, right? We could get into the Spice Girls and sing, but we don't need to. Okay, we will stop. Why do I stop? Because I'm in cos and as simplest. Simplest, that's a good word. This is simplerest than this, right? Binomial, monomial, simplerest. Good. So now we jump over to the right side. And by this time, we're all like, oh, I see it. Oh, you think you're so tricky. Well, I know that secant squared is the same as 1 over cos squared theta. Questions here? Okay. And as a result, I've got 2 over cos squared theta. Okay, you don't necessarily need to show that middle step, but it's nice. You can. We good? All right, and then, folks, I'm not going to take the time to write the since and therefore statements. Since left side equals right side, therefore. You get what I mean, yeah? All right, moving on. Number 12. Okay, I would say number 12, both sides are equally complicated, complex. So I'm going to do my chart right in the middle. Left side equals right side. What do we got? We got tan squared theta. Oops. Good morning. You can just put it right into the recycling bin. It's nice to see you. Sine squared x. We are on the last page, just going through questions that were requested. And before I start, so what would I do if I was in this test? I would make a little game plan before blindly moving. So I'm like, I see tan. First thing I'm going to do is work with the tan. Then I see a lot of squares, right? So what's that going to do for me? Okay, I don't know, but I'm going to see. Sorry, this is a big minus. So first thing I do, let's change the tan. Is it sine over cos? Thank you. Tan squared is sine squared over cos squared. Good? Now, because there is one fraction, it means we have 2. What's the other fraction? Well, the other fraction is just sine squared over 1, right? And so now I do the common denominator. So I guess in theory, I multiply this fraction by 1 and 1, but that's redundant. But I multiply this rational expression by cos squared x over, whoops, Miss Sly, cos squared x. Do I know where I'm heading with this? Not fully. I'm kind of just like, we're just doing stuff, right? One step at a time. Cos squared x. All right, got a denominator. Now, I've got sine squared x minus sine squared x. Oh, this is so good. Okay, this is the moment, folks. If you're not paying attention, pay attention now. This is a new concept. Not new, but this is a good one. Okay, what can I do here? What can I do here? Get rid of the signs? I wish. I wish. Okay, so 1 sec. You got it, Greg. I'm just going to let everyone else get there. So watch this. Sometimes it's easier to change these things into x's and y's. So I'm going to make the sine y and the cos x squared. What can I do here? common factor. What is, so I have a binomial, right? Actually, I'm going to take that dot out. I have a binomial, two terms. Each term has a y squared. Oh. Okay, do we see this? Okay, who sees this? Okay, and can you see how we can now use that in the numerator? What's the common factor in the numerator? Say it out loud. Sine squared x. It's so ugly, folks. But then when you get it, man, do you feel good. So, folks, factoring is coming back to haunt you in this unit. All right. So, our common factor is sine squared x. And that leaves us with 1 minus cos squared x over cos squared x. Guys, I really, really just want to cancel these. Can I do it? No, I cannot. Good. Now, at this point, I'm going to look at the right side to see where am I heading. Okay, I've got that. You know what? I'm going to jump in to the right side to get rid of the tan, to get a better sense of how I can get both sides equaling each other. Okay, sine squared x over sine squared x over cos squared x. And do you know what sine squared x times sine squared x equals to? Well, yeah, if I've got x squared times x squared, well, that's just x to the power of 4. So here, I've got sine 4x over cos squared x. Isn't that beautiful? Love it. Love it, Miss Sly. Okay, but at least now we've got the right side only in sine and cosine. So we kind of know where we're heading to. Now, does this help us know what to do here? Okay, what do we want to, what's the plan of attack? Where are we going?
In the brackets.
In the brackets. What are we going to change that to? Yes, we are. That's right. 1 minus cos squared x is just sine squared. Oh, trig identity. You thought you were going to trick me. Nice try, dude. Not a chance. And this becomes sine squared x using the Pythagorean identity. And then we're like, oh, dang. Sine squared times sine squared is sine to the power of 4. Folks, when you started this course, did you know that you were going to be writing sine to the power of 4? Probably not. It probably didn't enter the realm of your imagination. All right, are we good? Can we stop? Can I stop? YOLO. We got it. Okay, left side equals right side. And it's only in cosine sine, right? So I got a beautiful since and therefore statement, blah, blah, blah. Yeah, and then I do my little happy dance. I did it. Yeah, yeah. Nice try. All right. Moving on. Okay, we're skipping 13. Unlucky 13. And I'm feeling like a new color. Ooh, give me a color. Red? I just did purple. Green? But I did, like, what kind of green? Like that? Sage? I did sage green. No? You read my mind. Like this? Like magenta?
Yeah, like magenta. That's like maybe one more brighter.
Is this a good one? Is that good? All right. You are?
Yeah.
Are you really? What can you not see?
So we just pass it up.
So can you see purple? I mean pink?
Well, yeah.
But
Depends what it's next
pink
to.
is a shade.
Well, it depends what it's next to.
So when you have red and green, you don't know.
Yeah.
How come I didn't know this until now? Now I can like play with that and be like, so when you're looking at the green part of the lesson, I'll give you like a green test. And I'll be like, everyone with the red test, change this. Yeah. You'd be like, it's blank, Miss Slime. I like that. Yeah.
If we have cosine to the power of 2, say for example, we turn into 1 minus sine to the power of 2. Can we turn this sine to the power of 2 into another 1 minus cosine to the power of 2?
Yeah. Yeah, you can.
And like to infinity, we can do that.
Yeah, but we generally don't, but you can absolutely do it. I feel a bit stuck on this one. Anyone have thoughts? Pardon? I'm stuck on this one. Like, I don't actually know how to start.
I think you should change the 1 into something else. Maybe. On the left side.
We could change it into sine squared and cos squared.
Yeah.
That's what it is. Love it. That's what it is.
And
Oh,
then
you're
you can cancel out.
no,
No, because you have on both sides.
No.
Oh, wait.
no. That's exactly what we do. Oh, good. I was gonna like look at the hints. I'm so glad we didn't. Okay, remember. This is a side note. Sine squared theta plus cos squared theta equals 1. Yeah? So using my red pen, I'm going to write sine squared theta plus cos squared theta. Liam, I'm using my red pen right now, okay? No canceling out yet, folks. Why can I not cancel out? I really want to. Yeah. Everything is not factored. There is addition. All right. Anyone know why this is? Like, this is a tricky one. Yeah. Yeah, it is PST. Good for you. All right. PST. What the H are we talking about? Perfect square trinomial. Watch this. If I have x squared plus 2x plus 1, I can factor it to x plus 1 all squared. Okay? I'm going to give you a more complicated one. If I have x squared plus something plus y squared, and I want you to think about what will that middle term be? Yeah. So watch this. When we're working with perfect square trinomials, if you are squaring a binomial, SAB, remember SAB? Square a binomial. You square the first term, you square the last term. Then, to get the middle term, you multiply the two terms and double them. So you go this times this doubled will give you 2xy.
You say that cosine is the middle term in this one, yeah?
No. Now we must take this numerator and rearrange it because cos squared is not the middle term. The middle term is the one that has the 2. So I've got sine squared theta plus 2 sine theta cos theta plus cos squared theta. Is this going to show up on the test? 100%. Right? Why not? Like, would this maybe be a thinking question? Sure. Should you review it? Absolutely. Okay, do you see what we can do with the numerator? Okay, let's break this down together. What is the first term of the binomial? No. Sine theta. Right? It's the square root of sine squared theta. What is the second term of this binomial? Cos theta. And is it going to be a plus or minus? Because this is a plus. If it was a minus, you would have a minus in there. Let's look at the right side. Let's get a sense of where we're heading. Okay. Almost there, right? What can I do now? Now I can cancel. Why, Lila? Everything is factored. I know. Once everything is factored, then you can cancel. And I'm going to be a bit more explicit here. Sine theta plus cos theta times sine theta plus cos theta. Folks, you do not need to show this step. Right? If you just cancel out the exponent, that's cool. Right? But here we can see, oh, when you square a binomial, it means you're multiplying two of them. And now we can cancel out the denominator. And that leaves us with sine theta plus cos theta. Yeah! Which is the right side. Isn't that crazy? We did absolutely nothing on the right side. Thank you for entertaining my isn't it crazy?
I have a question.
Yeah.
When I did this one, I did it like the opposite way, but I feel like would I only get partial marks if I only did the right side? Because I made the right side into like 1 plus 2 sine theta cos theta over sine theta plus cos theta.
Let me look at it later. But if you got this, I mean, Jen, that might be communication marks because the strategy is you always start with the one that is more complicated.
Yeah.
So you would have started with the left side. But if you were able to get them to be identical, then you would get it right. It's just I might say that's not as efficient. In communication, I'm looking for efficiency, right? Okay, since, therefore, blah, blah, blah. Next. Okay, so I still have to do 15, 16, 17. Okay, let's do it. No time to lose, except that we need a new color. Do you know what I'm really feeling? I am really feeling like a nice royal blue. This is kind of not royal blue, but it's nice. I don't love it.
You like orange or something. Like a nice bright one.
Like I'm kind of feeling that. Yeah, your input doesn't matter. Wow. Wow. Oh, that hurts. Oops. All right, isn't this a fun one? All right, I'm just gonna go with it, right? I don't have a map in my head of how we're gonna get to the solution, but what do you think is the first plan? I'm not sure. I kind of want to, oh yeah, exactly. Get rid of the reciprocal ratios, right? I was like, do I start with common denominator? I think not. I think let's look at this first rational expression, the one with the secant. And let's get 1 over cos theta plus 1 over sine theta plus cos theta.
That's all right. It's not sine theta plus sine theta. It's just.
Oh, no wonder. Oh my gosh, no. Okay, yes, because I really had no idea how to do this. Got it. So here we will also write it as 1 over cos theta minus 1. Okay?
Can you not just flip that?
No. You cannot just flip them. Yeah. Yeah, so are you like, can I just do that? Yeah, because of the plus 1 minus 1, you cannot just do it.
But if there was no plus or minus, you just flip it.
Definitely. Well, if you had secant over secant is just 1. No need to flip anyway. All right. So in this case, we're really just working with this first fraction. So the 1 is the same thing as cos theta over cos theta. Agreed? Actually, I'm going to break it down. So in the numerator, I've got 1 over cos theta plus cos theta over cos theta. Yeah? In the denominator, same thing, except I'm minusing. We good? Okay. Do you know what this means? Just going to write same. All right, now we're adding. Okay, so in the denominator, I get 1 plus cos theta over cos theta. Sorry, in the numerator. In the denominator, I get 1 minus cos theta over cos theta. Is it starting to clear up? Now, because I'm dividing fractions, I can take those rational expressions, and instead of dividing, I will multiply with the reciprocal. Yeah? Wait, take a pause. If you're saying sure just cuz, take a pause. Try to take in what we just did. Ask me questions. Why did you do that, Miss Sly? Can you say it again? Who's following? Did I go too fast? No time to copy. I will post this. Okay? I just want the understanding. All right. And now what can I do? Cancel out the coses. Right? So now I've got 1 plus cos theta over 1 minus cos theta. And finally, I will write down what I had here. Cos plus 1, cos minus 1. What time does class go till? 10:10. Yeah. It's All right, folks. How many people are like, the denominators are identical? No, they're not. Dang. Another trick Miss Sly taught us in Unit 1, rational expressions. What is it? Who remembers? Okay, we are going to common factor once again, folks. We're going to common factor a -1 from the second denominator. Okay, let's just do some work on the side. So this can also look like this. Negative cos theta plus 1, which equals -1 minus cos theta. Do you see what I did here? Right? Factored out the -1 Yeah. Greg, do you want me to like explain it? No, but like if keep in mind, if you folks, if you're not getting it, that means at least 3 other people don't get it. You got it? All right, so now this negative, okay, so watch this. So the first rational expression, we're done with it. The second, watch this. The negative from here goes in front of the fraction. Now, I'm just going to reorder these guys because it doesn't matter. I'll just keep it the way it is. I've got cos theta plus 1 over 1 minus cos theta. So I took this factored expression. The negative moved in front of the rational expression. Okay, are we good? Tricky, right? Okay, we now have a common denominator. Whoa. That was not a straight line. And then I've got 1 plus cos theta minus, oh man, so many tricks. Why did I put those brackets there? Because I'm minusing the entire denominator. If I didn't put those brackets, you know what the mistake would have been? I would have minused the cos theta, but not the 1. Yeah.
Would it have been wrong to just like multiply both of the ones, like both, like what's it called, the each?
Like to find the common denominator?
Like yeah. Like,
no, it wouldn't be wrong. It wouldn't be wrong. It just would have taken more time and more simplifying. Yeah. Okay. Well, now I've got 1 plus cos theta minus cos theta minus 1. Oh my God, I'm seeing it. The coses cancel out. The 1s cancel out. What are we left with, folks? Null. 0. 0 over 1 minus cos theta. Pardon? But it doesn't matter. I've 1 over anything. It's still 0. Right? Yeah.
How did you turn the cos theta minus 1 minus cos theta?
This pink stuff, right?
Yeah.
Oh, sorry, the green stuff. So I noticed, okay, I looked at these denominators and I'm like, they are so close to being identical, except that the signs are switched. So I'm going to take the second denominator and I'm going to factor out a -1. And that would make the cos negative and the 1 positive. Okay, so I factored out -1. That's where I got that negative in front. And then that negative went here. Right? It went to the front of the fraction. Yeah.
So then why is it 1 minus?
Because I factored out that -1. Yeah. Folks, do you see what Liam, and I don't mean to put you on the spot, but I am. Folks, did you see what Liam just did? Right? He asked a clarifying question. And do you know who wins? Liam and everyone else who was listening. Okay, so please don't be shy. I love when you ask these questions. Okay, sometimes I don't have time to answer them, but this really helps when you ask those clarifying questions. Since, therefore, blah blah blah. All right, that was 15. Is 16 the last one? Or did you also ask me for 17?
17.
Okay, we got 16 minutes. Man, we are rocking. Okay, but we need a color change. Let's do a nice green. It's like an emerald green, right? Yeah. That was good, Astrid. All right. 16. I think he's done with my joke. He's like ignoring me now. He's like, okay, it's old, Miss Sly. But it's new for me. All right. So, folks, 16. Both sides look equally ugly.
Miss Sly, if you don't get time to do 17, like
I'm gonna be at the robotics table at the beginning of lunch. You want to come visit me? But also, Sophie, keep in mind. No, I will have time. I've got 15 minutes. Yeah. And the solutions are posted right now.
I saw the solutions right now.
Oh, good. Okay, thanks for checking. Am I copying it right? All right. So, folks, refocus. You got this. This is an intense lesson. You are rocking it. Okay. When I look at these two sides, not only are both equally complicated, but also both of them have tan. So I'm going to do a bit of work on the left side, and then I'm going to do a bit of work on the right side. Like I know that I need to do that because I need to get rid of tan regardless. So let's just do some work to get rid of tan. So on the right side, I've got sine over cos times sine theta. And then in the denominator, I've got sine over cos plus sine. God, is that ever ugly? No, miss, I don't. Okay, at least in the numerator, I can cancel. No, I can't cancel, but I can square the signs. Okay, in the denominator here, it's a fraction. I must find the common denominator, which is cos. So I'm going to multiply like that. Yeah, and really, watch this. I just take the fraction sign, and that's what happens. I get sine times cos over cos squared. Okay. So in the numerator, I've got sine squared theta over cos theta. In the denominator, I have a nice denominator of cos theta. Now, folks, you may have noticed this. When you have a rational expression, i.e. a fraction, and both the numerator and denominator have the same denominator, right? So they both have cos and cos. What's going to happen to those two coses? They will cancel out. Yeah, that's kind of nice. So here I've got sine theta plus sine theta cos theta. Now, if you know this already, we can go ahead and cancel them, right? Otherwise, we'd have to multiply the numerator by the reciprocal of the denominator. Now, I'm not sure. Oh, I know what I can do. What should I do in the denominator? I've got sine plus sine theta. Someone said it. Common factor. What is the common factor? Sine. And this is helpful. We got 1 plus cos theta. Why is it helpful? What can I cancel out now? The sine, right? Because everything is factored. I can cancel out this sine and the squared. So I'm left with sine theta over 1 plus cos theta. That's kind of as simple as I can get, right? There are no exponents, so I can't use the Pythagorean identity here. So at this point, I'm like, all right, let's move to the right side and let's try to see if we can make it look identical. All right, so first things first, we need to work with the tans using that quotient identity. So tan is sine theta over cos theta minus sine theta all over. And you'll see this actually looks quite similar to what we had on the other side. Right, once again, we're going to get sine squared. In the numerator, what is the common factor? Cosine. Okay, so I'm going to multiply this. I knew that voice. Like that. We're good? Okay. So in the numerator, I've got, first of all, I've got a common denominator of cos theta. And I have, in the numerator, I've got sine minus sine theta cos theta. Folks, take a guess. What do you think we're going to do with the numerator? Yeah. We're probably going to common factor that sine, right? All right, let's go to the denominator. Here, I've got sine squared theta over cos theta. What can I cancel right now? The two cos thetas. Now, the numerator, I'm going to common factor the sine theta, and I've got 1 minus cos theta. Then I've got sine squared theta, and I cancel these dudes. Okay, now I'm stuck. 1 minus, I wonder if that's, I don't know if that's what I wanted to do.
It works.
I don't want to change it into 1 minus cos squared theta.
Well, it has to be squared.
Like, here's what I think. Oh, no, I got it. You're not going to like this. This sine squared theta, I'm going to use Pythagorean identity. And it's tricky because we are unsimplifying.
Oh, that's.
Whoops, I wanted blue. Okay, the reason why I did this is because of difference of squares. Remember that fun factoring? The opposite of flow rule, right? Let's review. If I have 9x squared minus 4, I can break that down into 3x minus 2 times 3x plus 2. So if you have a binomial and each term in the binomial is squarable, no, it's a difference of squares, right? Difference means subtraction. We're subtracting 2 squares. So this is where we undo the flow rule. So you have 2 binomials, identical. One has a plus, one has a minus. Now this applies in our denominator here. Because now my denominator becomes this. Watch. 1 plus cos theta, 1 minus cos theta. Do you see why that's beautiful? Because we cancel these guys out and we get left side equals right side. That was tricky. All right, and let's do one more. We got 6 minutes. That was kind of fun, right? Yeah, we're doing 17. Let's make it pink just because it makes us happy. Okay. Folks, I want to start on the left side, on the right side, because there's a factoring phenomenon there. Which one is it? Look in the numerator. PST. Do you see it? This is a PST. Perfect square trinomial. And so it can be factored. So what's the square root of 1? I should change my color. That's mean. What's the square root of 1? It's 1. What's the square root of cos squared? And then if the middle sign is a plus, that's a plus. And you add that. Okay, I just wanted to do that just so everyone can see, oh yeah, we got a factor using perfect square trinomial. Now, on the left side, we got a lot of reciprocal ratios. So let's get to it. Cosecant is 1 over sine theta. Cotangent is 1 over, instead of 1 over tan, cos over sine theta. So already the numerator has, what's it called? Common denominator. All right, folks, look at, okay, thank you. So folks, all I did for the left side is I just converted it. Shh, folks, you got it. I know I'm asking a lot from you. You're working so hard. All I did in this, on the left side is just converted it to the primary trig ratios. Okay. And I can see already, hey, each of them have sine theta as its denominator. So I've got 1 plus cos theta over sine all over 1 minus cos theta over sine theta. We can cancel out the signs because we know they're going to be canceled. 1 plus cos theta over 1 minus cos theta. I can't do more. So now I'm going to jump over to the right side. Okay, what can I do with sine squared? Good. I can change it into 1 minus. So I've got 1 plus cos theta all squared. In the denominator, I change it to 1 minus cos squared theta because I'm going to use a factoring method called the difference of squares. And then I can factor 1 minus cos theta, 1 plus cos theta. Oh my God, we're going fast. And what can I cancel? 1 plus cos theta. Did I get there? I did. Ooh, that was a tricky one. Well done choosing number 17. And good on you for trying it. Amazing. All right, folks. So you've got the solutions posted. You've got the hints posted. And remember, at the beginning of the lesson, we'll spend 20 to 30 minutes reviewing. I'll answer your questions. And then bring food because I will let you write into lunch. Is that cool? Yeah. I will post this video.